Okay, so this is the misconception question. This is meant to test for common misunderstandings that students often have. So you can speed this video up if you would like, or slow it down and go back. So number 2, in which of the following cases does a car have a negative velocity and a positive acceleration? So I'm going to draw a little diagram, a little vector diagram here. So the typical convention is left is negative, right is positive. So this would be a velocity going to the left and an acceleration going to the right. So for option A, it says something moving in the negative x direction at a constant 20 meters per second. So for A would have a velocity going to the left since it's in the negative x, but if the speed is constant, then we have no acceleration. Acceleration would be 0, so we can rule out number A. B, option B here, moving in the negative x direction and increasing in speed, that would be velocity to the left, but in that example for B, our acceleration would be moving the same way as the velocity. Okay, so for option B right here, this would be our vector diagram and acceleration would be negative. So it can't be B. C, moving in the x direction, well, moving in the x direction is going to have our velocity vector going to the right. So for that one, our velocity vector would look like this. That also rules out E. So the only answer it could be here is D. Moving in the negative x direction and decreasing in speed. That is what we showed right here. So again, when you have the velocity vector and the acceleration vector going in opposite directions, that always indicates decreasing in speed or slowing down. Sometimes people tend to think that positive acceleration is anything where it's increasing. So some people will read this problem and say positive acceleration, and they'll see positive acceleration and they'll see increasing in speed and they'll go, oh, must be this one. But that is incorrect. Positive acceleration is only indicating the direction of the acceleration. We have to look at the direction of the motion to figure out if it is speeding up or slowing down. Okay, number 3. At time t equals 0, an object is traveling to the right along the positive x-axis at a speed of 10 meters per second with an acceleration of negative 2 meters per second squared. Which statement is true? Well, I'm going to draw a little picture here. So traveling to the right, so it's got a velocity moving to the right, the positive x-axis again, right? Positive is right, negative is left. And it says that it is at a speed of 10 meters per second. Okay, 10 meters per second. And it's got an acceleration of negative 2 meters per second squared. So that means the acceleration is going the other way since it's negative. And they want to say, what's going to happen? Well, if I think about what's going to happen, this acceleration is telling me the rate of change. So drawing a little vector diagram kind of helps with this. If this acceleration is constantly pulling to the left, what will happen is this velocity is going to get smaller. And eventually it'll be 0. Okay, but if this if this acceleration stays in place, once the object has slowed down, it's then going to change direction. So if I were to draw the velocity vector of this object, it's going to begin accelerating this way. So what's going to happen here is that not A, the object is going to slow down and come to a stop, but there's more. B is just doesn't make sense as an answer. C, the object will continue to move right, slowing down but never coming to a complete stop. That is false. What is the correct answer here is D. As you can see, this object starts at time 0 right here. It will slow down, but if that acceleration stays in place, it is then going to begin speeding up in the opposite direction. And this is kind of like our free fall, right? This is kind of like a horizontal, this is kind of like a horizontal X version of our free fall, right? We have a constant acceleration. So if the acceleration stays in place, this object would indeed slow down and then change direction. Okay, number 4, a ball is thrown straight up. What are the velocity and acceleration of the ball at the highest point in its path? So again, I'm going to draw a vector diagram here. So we would start with a large positive velocity, right? I'm calling positive the up direction and negative the down direction. So I have start with a very positive velocity, and it's going to begin to slow down under gravity. So my vector, my arrow gets smaller. And then, as we know from the previous problem, it would actually begin to accelerate downwards. But we are only concerned about this blue point right here. I'm going to draw this in big blue right here. This big blue point right here. Well, at that point, the velocity is going to be 0 meters per second, as we've talked about for many times. For a split second, that velocity is 0. The acceleration, well, if it is in free fall, we said that it always has an acceleration equal to negative 9.8 meters per second squared. Now, you'll see me estimate that a lot with negative 10, but this problem is asking it more precisely. So the correct answer here is C. The velocity at the top, at that blue point, the velocity is 0, but the rate of change is still down because of gravity, 9.8 meters per second squared down. Okay, so note that I did I wrote mine as negative, they called it down. Different ways of writing the same thing. Okay, number 5, you drop a rock off a bridge. When the rock has fallen 4 meters, you drop a second rock. As the 2 rocks continue to fall, what happens to their velocities? All right, so if we're going to draw what's happening here, you drop a rock, and the rock is going to fall. So I got red rock right here, and we will say that we'll call this 4 meters. Okay, so the red rock has fallen 4 meters. So at that time, at that time right here, where the red rock is, you're going to drop another rock. You're going to drop I'll do this one in blue. So at that exact same time, you drop a rock, and it's going to be at velocity equals 0 meters per second. And it hasn't moved yet. The blue rock has not moved yet. Okay, so as the 2 rocks continue to fall, what happens to their velocities? So if I were to continue this red one in green right here, it's going to accelerate. And if I continue this blue one here, it will continue to accelerate as well. Actually, I should probably do that as the same size as the other one for a certain reason. Okay, so what is true here? Okay, well, if we look at both of these rocks, there's something that we can say, and we can say that they are both going to accelerate at the speed of gravity. Okay, so both of these rocks are going to be falling at the same constant acceleration. Okay, so this says the velocity of the first rock increases faster than the velocity of the second rock. C says the velocity of the second rock increases faster than the first. So B and C are kind of saying the same thing. They're basically saying that one of them is falling faster. But the rate at which is changing, as you guys know, the rate of change of velocity, that is our definition of acceleration. Okay, acceleration is the rate in change of this speed. Okay, so choice D is a incorrect answer, right? Velocities are not going to stay constant. It's going to accelerate. B and C are incorrect because the rate of change of the speed is the same. The answer here is A. They are both going to increase at the same rate. So even though this one starts at a faster speed, okay, the rate of change as it falls is still the speed of gravity. So this one is starting from rest, so it's going to start slower, but the rate of change is still the speed of gravity. Okay, number 7, a ball is dropped from the top of a building. At the same instant, a second ball is thrown upward from the ground level. When the two balls pass one another, one on the way up and the other on the way down, compare the magnitudes of their acceleration. Okay, they're trying to trick you again here. Okay, so if we have a building and we drop a ball, okay, again, it will accelerate if we look at the red. The other one, it's saying that a second ball is thrown upward from ground level. So this guy throws one up. And if we think about the velocity vectors throwing up, we said that it does this, right? Something like this. Okay, but if we compare the velocities, it is free fall again. So the acceleration, I think I said velocity a second ago. The acceleration is again always the same. Okay, so the acceleration of both balls is the same. In free fall, the acceleration is the same no matter whether the ball is going up, down, or sideways. Okay. That concludes the misconception questions.